So hello everybody at the third online panel discussion at AERO 2020. As you all know, AERO has been cancelled like many other events around the world due to the coronavirus. Over the last years with the eFlight Expo, we had a lot of presentations, panel discussions from people who work in electric aviation around the world. And we had debuts like the Volocopter, like Siemens aircraft, and like, for example, Uber and many others. And what we decided is we cannot be all together, but what we can do is we can do it and record the information and you can have it online. So hello to my panelists around Europe, and hello to the visitors and viewers on the screen, wherever and whenever you watch it. Now we start. We have here on the panel, we have Hans Dunder from Green Flyway in Sweden, Erik Lithun from Elfly in Norway, Martin Stephanek from Phoenix Aircraft in Czech Republic, and Qinyin from Rolls-Royce Electric, Qinyin Zhang from Rolls-Royce Electric here in Germany. And there are as well me and the editor of eFlight Journal, Xin Guo, on the panel. So I think let's get started. I stop my screen sharing and then we see the first presentation from Erik about what he thinks how electric aviation can develop in the Nordic countries. By the way, while Erik is getting his screen shared, you see on the image, the one with the mask is Martin. He joins us from the airfield as he's doing some electric test flying. Luckily, they still can fly under special conditions in Czech Republic. So, but he will have time to talk and give out the latest info later on during this presentation. Okay, Erik, we're waiting for your screen. Yeah, it's coming. Great.
You see the right screen?
At the moment, yes, it's the right one.
Perfect. I will not touch anything then. So, hi, my name is Erik, and I'm working with electric aviation as an investor and as a personal interest. I'm taking my pilot license, private flying pilot license, and I've ordered an electric E-Flyer 2 from Bay Aerospace in the United States. And then I started doing business with them and had great discussions with George Bay and his team, and we've ordered 18 planes. So we are trying to position ourselves in Norway as a first mover and to do business development around the possibility that will come with electric aviation. So to just give a quick brief understanding about why we are doing this, I think everybody knows about the problem. I just read the recent report from Avinor, which is the Norwegian government's organization that is running 44 airports in Norway, that the emission of CO2 in Norway, approximately 5% is domestic flights. So they want to cut the emissions for Norway on domestic flights to zero by 2040. And why do we think in Norway that this is a good idea? Norway was one of the first countries to highly adapt to electric vehicles, EVs. And in 2090s, electric vehicles is about 50% of the sale. If you calculate also with hybrids and plug-in hybrids, at the end of the year, it's actually even more. If you see the green graph here, by the end of 2019, you see that if you add the slightly green and yellow one, which is plug-in hybrids and hybrids, you see that diesel and gas cars is about 20% now of the sale. And after we've done this with the cars, we've started to do it with the ferries. But this is why I show the pictures of the ferries. In the window here, you see one of the first electric ferries that was built in the world. It's pure electric, takes 120 cars. And it's been operating for some years, and it's been a great investment for the company that built it and is running it because of lower maintenance cost and fuel costs. And this last one here is a brand new one, which is for tourists. And it is a pure electric vehicle ferry that is taking tourists around the fjords of Norway. So now the next challenge Norway will set forth to do is to have zero emission aviation, and that's the hardest one. And we will try this to solve two problems. In Norway, one problem is that we are polluting with the CO2, but the other one is that we need to do business in Norway. Norway is a very long country, which has a lot of people spread out to the north, very far north. And that means that if they're going to do business there with the fishing industry, the salmon, shipping industry, oil industry, and tourists, then you need to travel a lot. And the roads are narrow, and it will take you a lot of time to travel around in Norway where we are doing business and living our life. So aviation is part of the infrastructure. So Norway has a very high use of aviation per capita. We are using aviation as we were 10 times more people in Norway. So we are 5 million people in Norway, but we are consuming aviation as we were 50 million people. And this is where the potential and opportunity is. If you see these stars on this map over all the airports in Norway that Avinor is running, you see that the Trondheim, Oslo, Bergen, Oslo, Stavanger, Oslo is in 2015 was top of the 11th routes in Norway with consider number of people, and this is in and out of the main capital, and on to add to that we have all the other airports with a lot of traffic. So Norway, it's a market potential for relatively short flights with lots of people, and some people are traveling there for business a lot. So it means that you have a high possibility of people, but it's also hard to make money. So the government has something like subsidized routes that is giving out money to different companies, primarily Widerøe, to fly. If you look at the numbers in euro, the Norwegian kroner has been changed a lot, so I'm not sure if these numbers are correct anymore. But in southern Norway, there is a 4-year contract for 7 routes, which is like almost 60 million euros for a 4-year contract. And for the north of Norway, it's huge amount of money that Widerøe can have from the government to fly these routes on contract. So Widerøe, it's doing a great job, but it's one operator, and this is also the possibility to come in for new technology and new players. So it will be interesting to see what electric aviation can facilitate to make this even better for Norway. And as an example of a route which is not subsidized, I put up Bergen, where I live. This is Bergen here, and Stavanger, and that's approximately 500,000 people per year traveling up and down the coast, and it's driving by car 5 to 6 hours, and you actually pass 2 other small airports on the way. So this is a perfect route for small electric planes to ship people really fast and efficient. It's interesting to see that there is a lot of short runways in Norway also, but we have a lot of runways. So we don't need a VTOL in Norway. Fixed wing will do the job in Norway, and that's something you can say we can have like a 19-seater, which could cover a lot of people. Widerøe's smallest planes, which they have 25 of, is 39 seats. So I mean, it's a lot of small airplanes operating in Norway. So electric aviation is definitely possible. And we also have all the infrastructure, as I'm talking about, because we have a lot of short runways, which is like from 800 meters to 1,200 meters. So they are spread all around the country, and it's a really possibility to use them for electric aviation. And also the government has given out the report recently by Avinor and Luftfartstilsynet. That's like Norwegian Civil Aviation Authorities, CAA, I think. It's a report for program for introduction of electric aviation for commercial air traffic in Norway. And this came out last month, and it's a really interesting report about what incentives Norway want to give to implement electric aviation. I would just actually skip to that part. This is the reports like summarized in in English. And one thing is that Norway wants to take a leading role as an arena for developing this technology and the market potential. And we have said that we will have by 2040 zero emission on all domestic flights. And we will reduce the 5% that we have of the total emissions by 80% for Norway. So there is a big, what do you say? The goal, it's a reach goal, but we will try to get it true. And we have said that this is two different areas: technology development, which is the hard part of getting certified planes and the tech to work, and you also have the thing to get like the different players on the field with the batteries management system, the engine, the airframes, and also the operators of aircrafts, and general aviation also for the smaller planes, which we try to order the 18 planes from by aerospace to see what we can do with the Norwegian the different clubs that have fractional ownership and different ownerships of planes. Yeah, and we are also a member of the Nordic Network for Electric Aviation, which also Hans is a member of, which we have had some meetings and fine discussions about how we can do this for the Nordic market, which is a big market in the global perspective. So I'm really looking forward to the future work there with Hans and all the other people. So the key question is really, who has a certified plane for Norway? I mean, we have the business case. Can somebody apply us with a certified plane that we can start to actually do business with here? That's the interesting thing that I'm really excited about. Yeah, that was short for me. Any questions or anything, or we take that afterwards, Will?
Muting my microphone, yeah, just unmuting my microphone, yeah. So I think we take the questions afterwards. So I would like to see Hans' presentation now, then Qinyin's presentation, and then I think we go into the discussion, if this is okay with you. So Hans, if you could share your screen.
I have a problem with that now, so I have to take it orally like this to describe it. So what I would recommend is that when you are looking afterwards, you will look upon our homepage, yes, which is greenflyway.com. Then you will find it in English, the presentation of the product and what we are doing and working with. So I have to verbally now describe.
Actually, Hans, actually what I will do, I will put the homepage on the screen, and then so the people can see it at the same time while you're talking. I think it's greenflyway.com, and then the people can see at the same time the website. I think I should be able to share the screen, which is this. this screen now. And you see the
now, yes.
You see it?
I see at least.
Okay, then I think everybody should see it. So you tell me if I should change anything, but now you can start explaining, I think, and then we see how we go from there.
Well, this Green Flyway is a Swedish-Norwegian project, which is a cross-border initiative, which is financed by a lot of partners. It's 3 years. It's 2021, 2022. And we are actually going to develop a test arena for future aviation. And what we mean with future aviation in this matter, electric aviation, but electric aircrafts, but also we will also work with drones, and we will also work with air traffic management and use space. How do we combine autonomous vehicles in the air with non-autonomous? We also will work with how to green the infrastructure or greening of the airports. How do we become totally fossil free, and how do we work with electricity, and how do we work with the interfaces when we come to charging and so on? How do we work with hydrogen, sustainable air fuel, aviation fuels and so on? But also ground support around this. We will be also working like one-stop shop, inviting a lot of actors to come to our region to test their vehicles or their systems or their parts, which will, for instance, engines, electric engines or other kinds, but also entire aircrafts, both which are fixed wing aircrafts, but also electrical vertical takeoff and landing aircrafts, as well as drones. And we have a lot of partners in this project. Is, like I said, partly financed by European Union, an Interreg project, and it's the region of Jämtland Härjedalen and also Trøndelagsfylke, where in the mid-Scandinavia or mid-Nordic. And we are also working with, so we will look upon how can electric aviation be a disruptive technology which actually enhance regional development by connecting and connecting regions. Because we have the same problem in Sweden as well as in Norway, that we are sparsely populated, we have long distances, and we had until the 80s a relatively well-developed regional network for aircraft. But due to the costs for having commuting with small aircraft and turbine aircraft, and we have not the same PSO system like Norway, which is the public service obligation system. It's not as developed as Norway. So therefore, the market forces have brought that out. So we have only the hub and spoke system, which is actually working all over the world, so to say. We see here that electric aviation will make a big difference, and it will be really disruptive because of the possibility to achieve the same economy with a 19-seater hot aerospace aircraft, fully electric aircraft, on a short distance, like if you had an ATR 70 or these kind of 70-seaters or up to 100-seaters, and when you can have the same economy as them, and you can work with very small populations and very thin routes, and you do it in an economical way, we regard them, we will try to show that we will actually be able to do electric buses, of speed bus connections. It's public transport in its right meaning. It's like trains and buses and so on. But then this will be an electric bus with wings, and how we can connect. And for instance, we have a place in the Jämtland, the region of Jämtland where we are working, which is named Sveg, and then we have Östersund, which is the capital of the region, and the city center where you have all the universities, healthcare, and so on. But it's about 180 kilometers between these 2 points, and there are 2 airports, good airports actually, but it takes 3 hours going by bus or by train, and it will take about 2 hours to go by car, but it will take only 20 to 25 minutes to go by air. And therefore it's possible to commute, you know, within 1 hour from door to door. And we want to show that. So we are going to simulate that and demonstrate that. And therefore we have, for instance, Heart Aerospace as a partner in our project. This aircraft will be up flying in 2022. So we hope that we can use the prototypes and show really that validate our calculations. But we start, and they will be up and running with a certified aircraft in 2025 is their aim at least. And then we believe that that will be done. And the Swedish government has now realized this, so they are now putting 2 investigations looking upon how electric flying could contribute to the aims that we have, that we will have all domestic travel by air fossil-free by 2030, and all traveling, including international, fossil-free to 2045. To compare with the Norwegian goal that 2040 all domestic traveling should be by air, should be electrified. So in order to be able to do this, you have to start somewhere. And what we have this first actor that we had is that you see now in front of you is the Phoenix, which was the first out to test this, to fly up and down in December in winter conditions in Sveg, which is part of the Östersund, Sveg and Røros in Norway. And they were showing, and I was actually flying with Martin. Martin and I are the 2 guys who have been flying both the Pipistrel as well the Alfa Electro and this aircraft, this Phoenix. It's a wonderful airplane, I can tell you. It's very nice to fly. I'm a private pilot myself. I'm sitting in the vice chairman of the Royal Swedish Aero Club, working with environmental issues and also accessibility issues. I'm a society planner by profession. So I'm working with infrastructure, both road, rail, and sea and air transport. And so this is my so to say profession, but I'm a private pilot and I love flying. But we have started this, and in February actually we had the second time we went with, they flew from Sveg to Hedlanda to Funäsdalen and then to Røros as the first cross-country electric flying during wintertime. And we are now having a dialogue with other actors who are wanting to put now electric propulsion and you know, change the old Rotax versions for Blackwing, for instance, are having this dialogue. We have others, eVTOLs, which we are discussing with, and other actors also, which are looking upon the possibilities to test their equipment at our place. And we have this belief that we are now taking part in a game-changing, it's a paradigm shift, and our aim is to assist this game shift, and we are looking upon making this area of Norway and Sweden to become the test arena, which is have the same status as the test arena in the very north of Sweden, which is Arjeplog and Arvidsjaur, where you have all the major car producers testing their vehicles during wintertime, because we have a lot of tough weather, tough topography, and so on, which is a must when you are testing things and show that it really works in tough conditions. Because if you can handle things in this area where we are, then you can tackle every kind of problem around the world, so to say. And so this is how we work, and we will, as I try to describe now, work together with the Swedish airport, the governmental airport owner, which is Swedavia, and we are working together with the Norwegian Avinor, We are working in the Nordic Network for Electric Aviation, and we work in electrification of Swedish air traffic, which is another network. We are working together with Finns because we look upon also the possibility to connect between the Nordic countries, not only between Oslo, Stockholm, and Helsinki, but also between Trondheim, Östersund, Umeå, and Vasa, for instance. And to have cross connections in the middle and up in the very north, and by that using the relative advantage of electric aviation as a game changer. The problem we have and will have in the beginning now is, of course, endurance, and therefore you have to look upon relatively short lines where you can really make a difference. So we have a PSO which is going from Östersund to Umeå on the east coast of Sweden, and this is governmental subsidized due to that we need people need to get to university hospital, and we see that will be one of the first lines that we will use this electric aviation as a line. But we also look upon how can we use eVTOLs and so on, not only for urban transport, but because we have not that dense urban, but for rural transport, and how we can use it for what we call blue light activities for the police, for the search and rescue, for the ambulance, but also for distributing medicine and whatever. So that is in a kind of a nutshell. But we want to make it possible for the aviation industry to show, well, first of all develop, but then also to test, and also to then market their products and show that it will be something which will be very interesting and also cost efficient and so on. And we are also trying to work now with rolling out a roadmap for general aviation with electrification. I've been working very hard with the first electric aviation aircraft in the general aviation sector, which is bought by Sweden, AERO Club of Sweden. And it will be now during summer probably that we will have our first certified electric aircraft flying in an AERO Club in Sweden. That will be in Gothenburg this summer. It will be a Pipistrel Velis Electro. This is our aim. That was some kind of a description. You can go further on and see all the partners who are there. But we have also, for instance, the CAA and Civil Aviation Authority, which we are working closely with, and we have also the air traffic management, like Luftfartsverket and Avinor with us. We have universities, we have SINTEF, research and development institution and institutions. So we are working hard with this, and the first launching customer, so to say, is actually the Pure Flight and Phoenix. And you can see this. You have YouTube films where you can follow this flight from Sveg to Røros when you go into the Green Flyway area, and you can see a lot of interviews and such things, but in English, but in Swedish though. But when you look at this flight on the YouTubes, then it will be in English though. I could perhaps answer questions. Yes. I could describe more, but I think this will be a short description of what we are working with.
Thank you, Hans. And I think we will have, like I said, the questions afterwards. So now we heard two kind of players in the two most active countries in the north talking about electric, which are Sweden and Norway. So perhaps now, Qinyin, you could unmute your phone and share your screen. I unshare my screen again, and then we could hear, because Qinyin is working for Rolls-Royce Electrical, and at Rolls-Royce Electrical he actually took over, or better you explain it to us what you're doing there. I think it's better than if I describe what you're doing. So we have the right screen, but you have to unmute your phone still because we don't hear you. Qinyin? There is a button at the left corner of the screen. Now it's unmuted, yes. And now please change to the other screen again, because now we see your working screen.
Okay. Great.
Yes,
okay.
Perfect.
My name is Zhang. Okay. As Willi introduced, I'm working for Rolls-Royce Electrical. Actually, we were our department of Siemens called Siemens e-Aircraft. We've been taken over by Rolls-Royce in October last year. So my role at Rolls-Royce Electrical is responsible for the business area commuter. And same time, I also have the technical responsibility, for example, acting as a project coordinator of this EU-funded research project called ELICA, Electric Innovative Commuter Aircraft. And within this project, we perform various studies, starting from market research to aircraft design. And the goal of this project is, as described by the tender, is to deliver our PDR, preliminary design reviews stage aircraft design with near zero emission. And so I would just go through this presentation because it's quite what you have talked is, for example, the economic feasibility of such a aircraft and market accessibility. And maybe one aspect is also from the technology point of view, will this kind of electric commuter aircraft work at all? So I just use this project presentation to give you give you an idea about the technological feasibility. Okay, so the objective of this project is to deliver a concept design of a 90 pax commuter aircraft, which is defined within the CS23. It describes the upper boundary of such a commuter aircraft, which can be certified under this CS23 rule. What we are doing here is we try to deliver our low emission concept, and we will provide a commuter aircraft design which is first of all environmental friendly, and then to give it a product perspective, it should of course also be economically feasible and technological innovative. That's our goal. And why we think this kind of aircraft is quite essential for the electrification strategy is, once we developed such kind of a design platform for this 90-seater aircraft, we can easily downscale it to, for example, 4-seater, 11-seater aircraft, which belongs to, for example, to the Tecnam aircraft portfolio, or we can also upscale it to the Leonardo or ATR aircrafts with 50-seater and 70-seater. So that's basically the motivation behind this. And since it's a EU-funded project, of course, the goal is also to strengthen the EU position in the global race for such kind of electrification of regional mobility. So we have a just short description of the project consortium. In the lead is a Rolls-Royce Electrical, located in Germany. We have various experience from the past. For example, we brought the extra 330 LE aircraft into the air in the year 2016 already. And this year, another world record breaking aircraft is going to be airborne, which is called Excel. And in the consortium, we have very strong partners like the University of Naples, which has extensive industrial experience by their collaboration with Tecnam and Leonardo. They have both numerical capabilities and also wind tunnel hardware for simulation. And SmartUp and Airspace are two different startups. SmartUp is specialized in computational simulation and optimization environments. And Airspace is a startup which deliver the silent air taxi concept with a 4-pax commuter aircraft for the regional air mobility. Last but not least is the Siemens Industrial Software, which provides a lot of software solutions accompany the product lifecycle. So starting from digital twin to manufacturing softwares, and also within this consortium, they are developing an innovative electric architecture design tool, which will set, which has an in-the-loop failure mode analysis, so that you can be sure the architecture solution will satisfy the certification rule with certain failure rate. And this project also has a very strong industrial advisory board. That's Leonardo Aircraft, Tecnam, Piaggio, and eVector from different European countries. Actually, all the bigger propeller aircraft manufacturers are here present. Okay, so I'll go to the next point. Is as I stated at the beginning, the project is quite comprehensive, and it starts with a market analysis, which is also quite good follow-up to the presentation of Eric and Hans. So if we look at the regional air mobility, are we sure that once we deliver our air taxi aircraft design, well, it has a market potential? So there are tools for the transportation system analysis that can analyze different transport means. By the way, do you see my mouse?
Yes.
Okay. So if you discretize the whole European continent and divided the geographical Europe into discrete points, so each point has a population density, it has access, you can use open source data bank. For example, for the OpenStreetMap, you can then determine its accessibility via road, and the accessibility via train. So the road accessibility is, for example, marketed like yellow, train is blue, and the commercial aircraft is marketed as green. So the logic behind this color map is, if you start from Aachen and you want to go to another place in Europe, for example, let's say Madrid, then the transportation system analyzer can provide our solution. So how much time you would need with car, and how much time you would need with train, and how much time you would need with the commercial airline. And if you have an air taxi concept, how much time it would take you with the air taxi. So based on this analysis, just like I said, if you take the example of Aachen to Madrid, you were for sure, it's a distance maybe 800 kilometers, for sure you would take the commercial airline. But if you are moving or traveling in the vicinity of Aachen, you probably the most probable transportation mean would be the car. So this kind of analysis is visualized here, and for our city like Milano, you can also plot the travel frequency or the probability that you are going to use, which kind of transportation mean you are going to use into a line plot. So dependent on the distance from 0 to 1,000 kilometers, this is more or less also basic logic. That means for a distance below 100 kilometers, you would take the car, which is yellow. And then for distance above 500 kilometers, you are for sure take the commercial airline. And then dependent on the train or rail infrastructure, you have certain probability that you will take the train. Obviously, in Milan, the train infrastructure is not that developed. So you will see a market gap somewhere between 100 and 500 kilometer. And air taxi, which utilize the local airfields, can perfectly fill this gap. So, and also this is just analyzed from Milan. And if you see again on the Europe map, you can identify the same trend. So if you travel from Aachen westward to Brussels, it takes you 1 hour. So very, you would like to take the train. Even for London, you see here, there's blue dot. So if you take the Eurostar, probably that's the most preferred transportation mean. However, if you go into the eastward, where, for example, the road is not, infrastructure is probably not well developed, and also the train also not. So especially then, you would have a quite big probability that you will take such kind of new developed air taxi. So that's a basic market analysis behind it. Second step, once you say, okay, there will be a market potential. So in this case, we chose Germany for the first analyze, and you will see we'll also perform analyze for Scotland and also for Norway. What you see here is Germany has altogether 400 airports and airfields. They are international airports. It's here dark square. You have domestic airports in triangles, and you have a lot of CS23 general aviation airfields. It's quite densely distributed. And in this plot, you see here the percentage of airfield in relation to their runway lengths. For example, for runway length, for airports featuring runway lengths above 2 kilometers, you only have less than 10% of the overall airport and airfields number in Germany, which is logical. You only have international airports possibly, which has longer runway than 2 kilometers. And if you go below, if you see here, you reach almost 100% of all airfields has a runway length more than around, let's say, 500 meters. And we believe, for example, for a 90-seater commuter aircraft, probably you would need 800 meter of runway. In that case, you can access, with such kind of commuter aircraft, you can access 40% of all German airfields. So that is, for example, one of the design parameter which we can choose. So if we want to access 50% of the airfield, we would choose the maximum takeoff length for 800 meters. And another plot here you see here is for this kind of, for this 50% of airfields, you can also plot the population distribution for Germany. You will see then here is a distance to such kind of airports is plotted from 5 to 40 kilometers. And here is a population in Germany. So I just shortened it up. So within 220 kilometers of such kind of airfield, you can access 55% of the German population. So the more population you can reach within a short distance, the more potential customers you will be able to access. So yeah, so this gives us a confirmation about the market potential of such aircraft. And the same analyze, of course, once you establish the analyze framework, you can deliver the same analyze for Europe. With, you see here that all the distribution of airfields in the whole Europe, and even we can also extend the analyze for the world. So we just pick two special countries which are promising. One, let's say, also Eric identified it, probably says home country by accidentally. Norway. He already analyzed the Oslo to Trondheim and all the short haul distances. We totally agree with Eric. Norway people are really enthusiastic in flying. So, and also they have a lot of quite busy routes in Europe and on very short distances below, I think, 400 kilometers. So this is really, from this point of view, really promising country to have electric commuter aircraft applied. Another interesting country is UK, especially Scotland, with distributed islands and also with airport on it. Lastly, I found they also want to zero emission aviation to the year 2040, so they can be a geographical competitor to Norway to have establish a zero emission aviation. So within this project, as I said, one aspect is market analyze. Second one is technology, and we want to identify the technology enabler, how we can make the new aircraft more efficient, utilizing the electric propulsion. It's the switch from piston engine to turbine engine led to paradigm change in the aircraft design. The modification is similar order of magnitude could be expected for the electrification. And due to the compact form of electric propulsion unit, you can think about distributed electric propulsion. And within the consortium, it's quite important that we know we have the appropriate tools to capture such effect. So University of Napoli started their analyze distributed electric propulsions. They detected if a propeller on, you will have an increase in CLmax, and we have different. If you have different distributed electric propulsion units from 8 to 20, you can capture the effect. Just to sum it up, if you have even more, does not mean you will the configuration will deliver more, because at some point it will worsen the efficiency due to the small propellers. So actually, if you see here, the maximum effect can be seen by 16 distributed electric propulsion, and so on. So we are confident we have the tools to capture this kind of effects. And also another case study showed also for this kind of aircraft, their tool can capturing and analyze and optimizing the aircraft design. So this, and then from the aircraft, you go one level lower, you would come to the electrical powertrain. So that's the domain of Rolls-Royce Electrical. So the design challenge is our coordination on system, subsystem, and equipment level. And you need to trade, and you must follow our holistic optimization approach. So let's say if you have a propulsion system design, you would need to consider the system architecture. You will need to ensure that the systems can be certifiable due to the failure rate, and no single failure should lead to total loss of the system. And all this are supported by the equipment design. So on the machine level, you have other design objectives. That means you want to have a very power dense electric machines, high efficiency, high safety, and easy to integrate equipment. So the whole the optimization of the electric powertrain should start from the architecture to the equipment. And we have the, within this consortium, we have the appropriate tools to do that. For example, as an example is, for example, Siemens Industrial Software is developing our automatic system architecture analyze tool, you can easily detect the failure probability already in the very early design stage, so that you can be sure, if you have analyzed thousands of possible architecture solutions and you already detect their potential failure probability, so you can then concentrate on our much less number of architecture solution proposed solutions and concentrate on detailed design here. So you see here the failure rate is around 10 to the power of -8, which is could satisfy the certification rule. Okay, and then you have from the system architecture, you have the EPU level. That means EPU, we means is the so-called subsystem, which consists of an electric machine, inverter, and even cable. On this level, we also have the analyze and optimization tool. To shorten it up, we have used this tool for the Centerline project. It's a passenger aircraft with 8 megawatt propulsion power. And one finding is, for example, the cable weight can be very dominant. It's even more than half of the system weight, let's say 65%. And if you choose the accordant voltage level to, for example, to 2000 volt, you can significantly reduce the cable weight so that you reach our system optimal. Okay, here what you can see is the system Pareto front. We are adapting this tool to the commuter aircraft. What you see here is a Dornier 228. We have performed a whole architecture design loop for this kind of aircraft. The goal was to replace the left propulsion unit, the turboprop engine, with an electric propulsion unit with batteries and generator on it, and we already finished the first concept design. Okay. So then, with all the tools and components I just showed, and we have still our aircraft preliminary design environment. This is again the University of Napoli. You can perform first design and then considering the regulation constraints, powertrain equations, weight estimation, and then perform the flight mechanics design to ensure it has an accordant performance, which is in line with the top level aircraft requirements and so on. So then you can get different aircraft experimental concepts and analyze their performance. So we already have some intermediate results, but I want to just skip it for this discussion. And then thank you for your attention.
Thank you very much. That's very interesting, I think, and I think it's a good add-on, because when we talk about the market potentials in Norway, we sure also have to talk about what is possible on the technical side. And I already have several questions on Qinyin. But before we go to the question, perhaps we give Martin a quick chance of giving us some explanation on his aircraft, which is the Phoenix, which was flying in Sweden and Norway recently, and see where this aircraft is, because like Hans was explaining, this could be or will be one of the first aircraft flying on the Norwegian market. As most of you know, there are, perhaps, Qinyin, if you stop sharing the screen, I then could put in while Martin is talking, because I think he cannot share his screen. I could share some images of the flying in Norway, and you could give us some explanation, Martin.
Okay, hello. I hope you hear me. Maybe I can remove it now because I'm alone in the, oops. In this building. We are on the airfield. Sorry, we've been supposed to fly today, but weather is not so good, and temperature is really low. So, what to say about our airplane? In 2010, we had a dream to make electric plane, and because we didn't know it, that difficult. We just did it, and well, I don't know if we would start it again if we know what we know now. But it's really challenging, and finally, the final version of Phoenix has already very interesting parameters. So we've been able to make very, very nice flight testing in Sweden and Norway, and I really have to say thank you a lot to Hans and his team, because they allowed us and they helped us to obtain the permission to fly in Sweden and Norway. Actually, we also obtained permission to fly on International Airport Bromma, where we did a very, very nice presentation, and we've been flying over Stockholm. It was really something unforgettable. And about technical parameters, we have 35 kilowatt-hour batteries, which allows us to fly for 2.5 hours with some small safety reserve. I'm normally flying about 2 hours. For one very charge, we can do over 10 takeoffs with 2 persons aboard. So we are, I can say, at the beginning of the chain where you have big airplanes like 20-seaters, then you have 4-seaters. So we are at the beginning with our small 2-seater, which is I think suitable for private electric flying, sport flying, maybe also training. The idea was that even if we are not aiming to do all the time the maximum length flights like 2.5 hours, because the one thing is to have a plane which is able to do it, and second thing is to have some like that is the idea, to make the lifetime of the batteries as long as possible. And to make it as long as possible, to achieve this goal, you cannot use the battery from 0 to 100% all the time. Ideally, of course, you are recharging to 100%, but then you discharge up to, let's say, 20-30%, and then you start charging again. You don't go to 0. So actually, after 1 year of flying, I can say that it's working perfectly. I enjoy every minute in the air. We have now over 100 hours. To make it universal, we followed the system which we used on Rotax version, which has a removable wing extension, so you can fly as a normal plane with 10.6 meter wingspan up to the motor glider 15 meters, in future also 17 meters wingspan. You can change it very, very easily. It takes you 2-3 minutes to change one plane to the other, because the wing extensions are very light and easy to be exchanged. And during the flight from Sweden to Norway, that's a good picture. During the flight from Sweden to Norway, we found out that you really have to be very careful with the infrastructure. It's good to check the availability of what power is available on the airfields, and also if the cables are properly wired, because we could make the flight direct from Sveg to Røros, which is 170 kilometers. But we wanted to try the landing on the ice and snow and all special conditions which we don't have in Czech Republic. So we landed on ice runway. I'm sorry, I don't remember the first one. But then we landed on the frozen lake, where is no runway. This is just a lake. And our friends, they prepared beautiful, beautiful runway that we've been able to land there. But unfortunately, they supply the energy from the cable which has by mistake connected one phase to the 0. So we burned our charger. And the last most challenging part of the flight over the mountains between Sweden and Norway, with a really hard crosswind, we did with not fully charged battery. We had only 70% battery charge and a lot of headwind, but still we did it with 30% reserve. And then I did one more flight in Norway. So I have to say that this plane is not, of course, aiming to big transportation. Maybe we could make a bigger version with 4-seater, but I don't definitely believe we are able to make some like a 20-seater plane. However, we have to start somewhere, and even pilots, they have to start to understand that electric propulsion, even if you want to do it very similar to, let's say, combustion propulsion, like with Rotax, it will never be exactly the same. You really have to you have to watch a little bit different parameters. You must explain pilots how the system works. And if they know, they also are prepared for what can happen. As I mentioned it, we started in 2010. So first flight of two-seater electric plane we did in 2011. And I have to say it was, every year was some challenge. So finally I can say we are at a point where I'm taking people, I'm showing people how beautiful it is to fly with electric propulsion. Nobody's complaining about noise, which is great. What was interesting, maybe it's interesting, I can say. Yesterday we've been assembling something with my children in the garden, and I saw one plane flying around. It was ultralight, whatever, with Rotax. And I found out that because now with coronavirus issue, there is no flying in Czech Republic practically. That even this started to be a little bit disturbing. That when you listen the silence, where is practically very limited traffic, even on the ground, and in the air is no traffic, and you see one plane flying around your house, you find out that it would be less loud, and it's not loud plane, but if it's less loud, you will appreciate it. So I think that this situation, what is now happening worldwide, will step by step change also the aviation, not the big aviation, which of course will be affected by no tourists practically for another maybe 1 year. But also for the local people, because now when they cannot hear anything from the sky, and it will start again flying with all these autogyros and whatever ultralights, I think that it will be more and more demand for very silent planes, and also for very silent planes flying the training. So that's my point of view, and that's our experience. I will not make it so longer. If you have any questions about our plane, I will be very happy to answer.
Thank you very much. And I think this gives, now we have had very nice parts of the game, which all have to come together when we want to get flying, and where we've seen that Norway can be a good market for such a first user. But on the other hand, it will be one thing which is also feasible in a lot of different countries. So as challenge and as motivation for those people working on aircraft, Norway can be the first market, because due to the special situation, also Sweden, the whole Nordic area could be the first easy use case. And if you see the challenges you have there with the cold, where even the car manufacturers go there for testing their vehicles, I think it is a very good test case then, because if it worked there, it's most probably also working in other parts. And we've seen there is a market also in other parts of the world, even in Germany, where you have a very large, good work of streets and railway, better than in most parts of the world. So I think there is a very good market there. So some addition you've seen before to the presentation of Hans, what he said about the flying of Martin in the Nordic countries. You can see the videos on YouTube already. We will have a story on our magazine, eFly Journal, and in German on Flügel in the very near future, let's say in 1 or 2 weeks. So when you're still locked up with Corona at home, you can't get flying, you can get to YouTube and get some very interesting information there. And with this, I'll leave it open for questions from all of you. Yeah, so perhaps ask questions. I have a lot of questions, but I'll leave you as my guests the first choice. Eric and Qinyin, you're both muted still, so if you want to ask questions, just for information. So no question, then I may ask the first question, which I have to Qinyin. When you've done the study on the 19-seater, and you said you also studied the technical feasibility. Do you think with nowadays batteries, it is possible to achieve a 19-seater who could cover these distances which we have mentioned, let's say distances up to, let's say 200, between 200 and 300 kilometers. Would this be possible with technology right now, or especially looking at the battery, or do you think we will have to start with smaller aircraft fast before?
Especially for 90-seater, that's a tender which the European Commission issued. We studied the 90-seater full electric version. I think the achievable range will be in the below 200 kilometer. And of course, you need still to think about the IFR reserve and also the loiter, required loiter, possibly duration and so on. And then the range is quite limited. On the other hand, if you go to smaller aircraft, you can also carry less. So currently we're also assessing the feasibility of a 9-seater, 9-pax aircraft, for example, how it will look like, and so on. This study is still ongoing.
When you say 9-pax aircraft, would mean 11-seater, let's say 9 passengers plus crew, correct?
Yes, yes.
Okay. Yeah, I have a question to Eric, because like, do you think when you would say, okay, because the other thing is, if you have a large aircraft, you always have to get enough people who want to travel. And especially in Norway, where you said there are not so many people and a lot of locations, would you think a smaller aircraft than a 19-seater, as we heard, a 19-seater can be quite difficult to realize with nowadays technology, and what batteries are promising is one thing, but what is feasible and certifiable is another thing. So do you think when you would take additional landing strips, there could be more feasible routes with smaller aircraft in Norway?
Well, on the list of the 44 airports that Avinor operates, the shortest one is 820 meters. That is by far the shortest one. But 800-meter plus runways, they have a lot in Norway. So if you go below that, there are even more airports around different locations with small populations. So if it's possible to do a air taxi-ish kind of service with an 11-seater airplane, I think that would be a beautiful case. And the government of Norway have said that the transportation system will be neutral compared to, there will be zero emission as the goal, but it will be neutral if you take a train, a ferry, a car, or a plane, as long as it's neutral in carbon emissions. And they have in this report a lot of possibilities for grants and subsidization of organizations that want to buy electric aviation as first movers. They also want to do subsidizing of tickets and things for passengers for the first electric aviation vehicles. So maybe for 11-seaters, there will be even bigger business opportunities in Norway, because that market doesn't exist today. So maybe in the future, not 50 million people will fly in Norway per year. It will be 100 million. I don't know. Maybe.
Yeah. Okay. Yeah. So Hans, yeah. Do you have what about Sweden in this area?
Well, yes. This is also one of these issues, because until now, air transport has been regarded something different from train transport, bus transport, car transport. But what we're working on now is trying to make them equal, so to say, and say that electric propulsion can make that air transport could be regarded as much as collective transport like trains and buses. And we also see that we can, for instance, with the Alice Evian, for instance, that is a 9-seater which have their capacity to go for 100 kilometers. Yes, 1,000 kilometers. And that would be of great interest for a lot of different routes. So we see that there's a large potential of going not only to hubs, but to fly from point to point and do this in a very specific way. And there is now this issue in Sweden that the Swedish government also is looking upon. How can we contribute? How can we work with this? Can we use this as a tool to enhance accessibility? Because a lot of regional development is based upon how accessible you are and what you can reach, and therefore and in a relatively cost-efficient way, but also must be environmental friendly way. And so therefore we look upon this, I mean, we have 10 governmental owned airports, and we have 30 regional, 33 actually, but then we have 160 airfields rather, which are owned by regions, municipalities and aero clubs or private airports, which are normally 800 meters or something like that. And so we could really open up also in Sweden. And, you know, for instance, this Heart Aerospace, they have, their idea is to optimize it for being able to fly for 750 meters airfields. That means all the short fields in Norway, but also in Sweden actually. So this is something that we look upon. But what we see, there are some obstacles now. Of course, it's the batteries and certified batteries. The other thing is the infrastructure. We have to come to a standard how to charge. I mean, in the car sector, we have the standards which is European, the CCS2, which is speed charging or fast charging. And we'll have to find some kind of that. And I had a dialogue with Heart Aerospace last week. I was asking them, what standard do you look upon? And they are looking upon the CCS2 with 1 megawatt of capacity, and which is for the heavy truck market actually, so that we'll be able to utilize the same. But we have to have a standard, and we in the Nordic countries, we were the first to implement the NNT system for mobile telephones, and then GSM, and becoming a practical standard. So one of our issues here also in the Nordic countries here is to perhaps to put up the factual standard for electric aviation also, because we have to deal with that. And that is one part that we are going to deal with in our project, how to be able to service and also have charging and finding the good solutions for charging.
Perhaps one remark to this, which is interesting. I don't know if you have contact already with GAMA, the General Aviation Manufacturers Association, because I think they have a strong initiative also working on this standardization. As there are all the general aviation manufacturers located in there, and they have a very core interest in there. So perhaps you definitely should connect with them when you work on this effort. And I have another question on Qinyin. Do you know, on this charging side, is Rolls-Royce taking efforts there in working towards a standardization?
I have no comment on that. I'm not familiar with the business, so I hold back my comments. Sorry for that.
No problem. So
I can say one comment on the charging standard thing. One thing that the authorities of Norway discovered when they in Norway now, there is 74 electric ferries being built or being in operation already. And one thing they discovered now with so many ferries put in production is that when they wanted to try to move one ferry from one route to another, then the operator said, well, they have the wrong kind of charging system, so we cannot move the ferry. And that is something they discovered now, that there are not a standard for the ferries, so they want to try to implement now for aviation to get like one standard-ish kind of thing. So actually, they don't have to build dual and triplet systems to support different kind of vehicles.
Okay.
Actually, yeah, you can. I just have a quick. Okay. Actually, I just have one quick follow-up question. for Qinyin, actually this is a kind of a follow-up question to your previous question, and also for Eric and Hans' comments. The question is, Qinyin, does your project or any other project you know study the economical feasibility of the electric commuter? The point is how many seats will be the minimum to make the operator profitable? Because I think to make this electric commuter prevail, the operators must be profitable, and that the profitability of this air taxi is directly related to the number of seats. And that's why we see over the years, all these regional airlines or air taxi operators, they tend to use larger and larger airplanes because the cost per seat per mile could be lower. So I think to the best of knowledge, do you have any such like number, for example, what's a minimum of seats could be profitable for electric commuter? Let's say 6 or 8 or even 4. That's my question. Thank you.
Okay, I'll pick up that first. Actually, the tender for the project was explicitly prescribed that it should be a 90s pax commuter aircraft. However, we developed also our cost model for this for the operation of the aircraft, and currently we believe this kind of aircraft can be operated at a price of 55 cents per passenger kilometer. So it's in the range of the cars and other transportation means. So it can be profitable because we are not only competing with the aircrafts, bigger aircrafts, especially on a short distance, also with cars, with trains, and so on. That's our probably even more competitive than the bigger airplanes. And the effect, what you said before, that airlines are going to use large aircrafts. That's true to reduce costs, but it has its limits because you can only fly or approach to larger airports. And what we are doing here is we want to utilize the regional airfields. Then you need other kind of aircrafts. Okay.
Oh, okay.
Hans here.
Yeah.
We have this is part of our project also to measure this or to make these kind of simulations, and we look definitely upon this as a possibility. This is why we are actually at this moment. I was last week talking with Anders Forslund about the Heart Aerospace and the cost for operating them and so on. There is a Finnish professor who has done this and compared with the ATRs and so on. So we will do it in our project. And I was doing, because this test flight that this Phoenix was doing, Martin was doing, he described, and you can see it on our homepage, how much energy it consumed, and also the flight which was taking place in Bromma was the same thing. Quarter an hour was consuming 3 kilowatt hours of battery capacity, and that would have been 10 liters of avgas to a price of 20 euros, while the cost of Martin's flying was below €1. It was 1/3 of a euro actually for an energy cost. And so we tried also, I've done that now to calculate and show, compare the Martin, the Phoenix was flying from this Sveg to Røros. During this way, it was 220 kilometers the way they flew, and as they were not flying directly, but it was actually the same road that the road transport also. So we have been comparing now the Martin's electric aviation or aircraft, the Phoenix. We also compared it with the same aircraft, but with a Rotax engine, and also with an electric vehicle like a Tesla, but also a diesel vehicle and also a petrol-driven vehicle. And we can easily see that the one which really consumes less or actually is very cost efficient is the Phoenix. So it's a lot of, then it's a question about how much does the battery cost to change and so on. So we are doing these kinds of calculations. We will come up with them, but I have them on my, well, in my computer at the moment, in an Excel sheet, and we are going to deliver the coming months a lot of figures around this. But it is possible, and it's also a question, of course, of the cost of investment in these aircrafts and the infrastructure. But actually, it's relatively easy to put up the infrastructure for these 200 airfields if you compare it with other infrastructure that is built.
I think one point you mentioned there is one thing where what I want to ask Martin. I hope he's hearing as he's walking around. You're hearing us, Martin?
Yes, I hear you. I only have to walk to my car because I have battery 2%, so I have to find some charger quickly.
So I just want to say, talking about battery, it's a good word, because you built this electric aircraft, and there is one of the challenges, I think you told me, is getting the right and the good batteries, and getting the batteries at a reasonable price. So how much did the battery, you know, when you calculate just how much the aircraft, not how the sales price is, but how much the aircraft to build could you, and how much percentage of this was the battery, or what price was the battery for this aircraft?
Well, if I remember well, we paid over 1,000 euros per 1 kilowatt hour, so the battery was about over 40,000 euros, only the battery.
Yes.
And the whole plane, as we build it with all the stuff, was around, sorry, I have to start the engine. Now it's better. Yeah. Was 220,000 euros with all the charges and everything. So, but I believe that if you compare to automotive, when they say they are around, I don't know, I don't want to say something wrong, but it was $200 US per kilowatt hour.
Yeah.
So there is a really, really huge possibility to get better prices. But of course, we are, I would not say even small producer in compare with others. We are probably micro producer. So to have a possibility to buy these batteries cheaper somehow would be definitely big help.
So this is perhaps one idea for the initiatives you have up there in Norway. Like you have a lot of electromobility there on the sea and on the land. You know, working on this, getting trying to get battery production or producers working with aircraft manufacturers and supplying batteries at a lower rate could really accelerate the whole process.
Absolutely. Absolutely agree. Well, you know, again, you know, we are aiming more to sport flying, or let's say maybe also training, and there, I suppose, also intensive use or in aero clubs, and this for the aero clubs will be, of course, I don't know how it's going in Nordic countries, but for example, European aero clubs, they have limited sources. Also, the interest for aero club like membership is not that large as in the past, and I believe that the showing that also flying can be environmental friendly can, let's say, increase interest in between young people, because now as they are affected by let's say opinions that flying is very, let's say, making a lot of pollution and CO2, etc. This can show them that that is not that true, and then is even opening the new challenges that, for example, if we have plane with the same battery, they can compete each other, how long they can stay in the air, etc. You know, it's
there is a question, like when you mention this, you're probably going, and your aircraft is a kind of electric motor glider. So I think gliding, apart from training, gliding and glider clubs can be the first customers for electric aircraft, electric motor gliders. So in the Nordic countries, Hans, do you know in Sweden, Norway, how many glider pilots or glider clubs you heard there who potentially could be one of the first interested people?
Well, in Sweden, we have we are decreasing both in not the numbers of aero clubs, but in members, due to that we are having aging aircrafts and aging pilots and so on, and only male pilots almost. There are less than 10% which are female. So and the population is 50-50, so to say. But we have seen now that electric aviation is making, well, it's actually making a real difference. It attracts women, it attracts young people. So we think this will be something which is of great importance, because, for instance, we had in the 1990s, we had 6,500 pilots in Sweden, 3,500 aircrafts. We are now down to 3,500 pilots and 1,500 aircrafts. We will continue this. We will, in the 30s, we will be, well, wiped out, so to say. And we have to do something against this. And therefore, we see this is really a game changer also for aero clubs. We will attract new generations and also the female population. And this is of great importance for our survival in the long term. We say this, but the same thing is the gliders are, the glider community is also diminishing, so to say. And this could be also one of these game changers for that. So we are definitely looking upon that, and also electric flying for flight schools and so on, but definitely for aero clubs.
Hans, thank you. I really like the idea that is attractive for
women.
Female pilots.
I just want to say, if you want to attract women, buy an electric aircraft. That's a new slogan.
Okay, that's a good point. Thank you very much.
I have because I think we don't have much time left, because we're already quite longer than we were playing, and now you're probably also busy as we are still on a Friday. So I want to have a last round of questions or comments. If somebody, I still have some questions on my list, but perhaps you could say which are the most important points for you. We start with Hans, then Eric, then Martin, and then Qinyin.
Yeah, well, we see upon that the battery issue is definitely something. Therefore, we are in our project now cooperating with Siemens in Trondheim, and we will also cooperate with Rolls-Royce in Trondheim, which are developing the part of the eFNX project. We are also wanting to, well, we are having a dialogue with the Swedish Northvolt, which is a battery producer, and also ASEA Brown Boveri, which is one of those charging providers and, well, electric providers, and having a dialogue, could we get their interest in towards aviation also. And we see that there are possibilities to do this. And so therefore, this is a very crucial question to develop batteries towards this relatively small sector that aviation is. Now they are concentrated on developing batteries for the, well, for cars, as there's the big money and the volumes. We can never become as rich in volume, but we can definitely become of interest, and it's a necessity for us. And I stop there.
Okay, so perhaps Eric?
Well, to summarize things, I think that Norway wants to take a lead position by having a market that is relatively clear and defined, and the government has put effort into this report, and there will be more initiatives coming out of Norway for the next year. I think it could be a good thing if I send you the report. There is an English summary of it, Will, and at the end, so you can put it on your webpage or so. Yeah, I don't have anything else to add.
We definitely will do, and we will also publish part of the summary in our magazines. So we will have a link there. And so now perhaps first Qinyin and then Martin as final comment. Qinyin?
Okay. Yes. Do you hear me? Okay.
Yes, we hear you.
Since we are in the business of electric propulsion, we strongly feel the unbalance between the eVTOL and the regional or commuter aircraft. That means there's a big hype on the eVTOL, while the perspective is rather yeah, it's more futuristic, but however, the challenge is much higher, and also the impact, I don't know if it will have such an impact like an electric commuter aircraft. So so we feel that the commuter aircraft will be realized much earlier and will have a bigger impact, but somehow this is not reflected in the public interest and also investor interest. So I think this could be a very critical aspect that, for example, Norway or Sweden, let's say, take money in the hand and drive this kind of business. This would be very essential, because without investment, I think the business will not develop so fast.
I can comment that I totally agree with you. There is a lot of eVTOL stuff, but there is a lot of more business cases with fixed wing, I think.
Yeah, and also from the complexity of the electric propulsion or power distribution unit and so on, considering the current certification requirement from the special conditions, this is much more challenging, but however, it's more, let's say, sexier than our commuter aircraft. So everybody is run into that. But let's see how we can push this commuter business market.
Okay, Martin?
Well, what to say? I have to agree, because as you can see, even if we started in 2010 without any investment or bank loan and everything, it took a long time to be where we are now. So I fully agree that it's a little bit too much focus on this eVTOLs and everything, even if the battery is not yet that good to really make it. That's just my opinion, that it's difficult to make it safe, this eVTOLs, etc. And if we start with something more simple, we can fly already.
Okay, so thank you. Xin, do you have any final comment?
Yeah, actually, perhaps I just have a very quick comment. I think perhaps I can give some credit to eVTOL, that we all, I think we all agree that there's perhaps too much this investment hype in eVTOL. However, I think as an electric aviation community as a whole, we perhaps can all give some credit to eVTOL, because as we all, because I think electric aviation really attracted people's attention, the whole society attention, ever since Uber published this white paper for eVTOL in 2016. And I think that's really the credit the eVTOL guys reserve, I think. And as a whole, I think in the end, the whole electric aviation community will benefit from the technology generated by eVTOL, because everyone can benefit it, like the battery supply chain and the autonomous flight technology, everything. So I think, yeah, as a whole, electric aviation community is really like a family.
Okay, so thank you very much all. So I have to finish, as you know, we're all standing in, there is my son, one of the future pilots. So for him, we're gonna build the electric aircraft, because we don't know when they will come. And as we most of us are working the home office now, I think I have to stop here, and we have to stop here, but stay tuned. We will get more information in the future, you at the screens at home, and I hope I will have some of you or all of you in a future discussion again. So thank you very much, and goodbye.
Bye.
Bye.
Take care.
Thank you, bye.